Okay, Wildcats, today we're looking at solving systems of linear equations with three variables on journal page 21. Solving systems with three variables, steps. Step 1, number the equations 1, 2, and 3. Step 2, eliminate the same variable from 1 and 2, 1 and 3, or 2 and 3. Step 3, number these equations 4 and 5. Step 4, now solve equations 4 and 5. Step 5, plug variable back into 4 or 5 to get the other variable. Step 6, take the two variables and plug into equation 1, 2, or 3. And then step 7, state the solution. All right, now your notes are updated. Let's take a look at the examples. Now, let me sharpen my pencil real quick. Okay. Now, there's a lot of work that goes into example 1 and example 2, but just note that on the next video, I'm going to show you how to do these same types of problems with the calculator, which will be a lot quicker and easier, okay? All right, example 1. So I see here that we have 2y and negative 2y. Well, they'll cancel. So let's go ahead and number this equation 1, 2, and 3. Okay. So let's go and combine 1 and 2. So that's 1x plus 2y minus 3z equals negative 2. And that's equation 1. And 2x minus 2y plus 1z equals 7. Okay. All right. Now, 1x and 2x combine to be 3x. 2y minus 2y, they cancel. You have negative 3z and 1z combines to be negative 2z. And negative 2 and 7 combined to be 5. I apologize if you hear the background noise. They're doing some work outside of the classroom. I think fixing one of the leaks that's coming from the ceiling. So we're just going to work through that, okay? All right, we're going to number this equation 4. Now, let's combine equations 2 and 3. But now we're going to multiply equation 3 by 2 so that the y's will cancel. So we have 2x minus 2y plus 1z equals 7. That's equation 2. Oh, almost forgot. This is equation 2. And then equation 3, we're going to multiply by 2. So 2 times 1x is 2x. 2 times y is plus 2y. 2 times 2 is plus 4z equals 2 times negative 4 is negative 8. And that's equation 3 times 2. Okay? All right, the y's cancel. 2x and 2x is 4x. 1z and 4z is plus 5z. And 7 minus 8 is negative 1. I'm going to number this equation 5. So now let's go and put 4 and 5 together. So we have 3x minus 2z equals 5. And we have 4x plus 5z equals negative 1. All right, now we need to eliminate one of the variables. So this is equation 4. This is equation 5. The only thing that will cancel here is a 2 and 5. So we're going to multiply the equation 4 by 5 and the equation 5 by 2 so the z's will cancel. So let's do that. So we're going to multiply 4 by 5 and 5 by 2. So when we do that, we have 5 times 3 is 15x. 5 times negative 2 is negative 10z equals 5 times 5 is 25. 2 times 4 is 8x. 2 times 5 is plus 10z equals 2 times negative 1 is negative 2. And this is equation 4 times 2 and equation 5 times 2. Now, (15 and 8) is 23x. The z's cancel, equals 223. We're going to divide both sides by 23. So x equals 1. Okay. Now we're going to plug in 1 into either equation 4 or 5. So it looks like, really doesn't matter. We'll just plug it into equation 1. So that's 3 times 1 minus 2z equals 5. So 3 times 1 is just 3. So we're going to subtract 3 from both sides. So you get negative 2z equals 2. Divide both sides by negative 2. So z equals negative 1. Okay. Now we're going to plug x and z into any of the equations and solve for y. I'm going to use the third equation because x and y don't have numbers in front. So this should be the easiest one to use. Okay. So we're going to plug in 1 for x. So that's 1 plus y plus 2 times negative 1 equals negative 4. Well, 1 minus 2 is negative 1. So this is y minus 1 equals negative 4. Add 1 to both sides. So y equals negative 3. So your solution is 1 comma negative 3 comma negative 1. Okay, go ahead and finish up example 1. All right, now let's take a look at example 2. All right, so let's number this equation 1, this equation 2, this equation 3. All right, now it looks like we can use equation 1 and 3 because the 2's or the y's will cancel, so let's do that. So we have 4x. Oh, forgot the x, let me write that. 4x minus 2y plus 4z equals 8, and that's equation 1. And then equation 3 is negative 2x plus 2y minus 6z equals 4, and that's equation 3. So we combine. 4x minus 2x is 2x. The y's cancel. 4z minus 6z is minus 2z equals 8 and 4 combined to be 12. And this is equation 4. Okay. Now, let's go ahead and combine equations 1 and 2, because if I multiply equation 2 by 2, the y's will cancel. So we have 4x minus 2y plus 4z equals 8, and that's equation 1. Now we're going to multiply everything by equation 2 by 2. So 2 times negative 3 is negative 6x. 2 times y is plus 2y. 2 times negative z is negative 2z equals 2 times negative 4 is, let's see, 2 times negative 4 is negative 8. So that's equation 2 times 2. Okay, so 4x minus 6x is negative 2x. The y's cancel. 4z minus 2z is plus 2z equals 8 minus 8 is 0. And this is equation 5. Now let's go ahead and put equation 4 and 5 together. Okay. All right, so that's 2x minus 2z equals 12. That's equation 4. Equation 5 is negative 2x plus 2z equals 0. And that's equation 5. Now you'll see that we don't need to do anything to eliminate the x's or the z's because 2x minus 2x is 0. Negative 2z and 2z cancel become 0. So you're left with 0 equals 12. Now this is a special case when all the variables are eliminated and you're left with a false statement. This is false, which was false, but now you can say that 0 does not equal 12. I shouldn't have put false. I don't know why I wrote that. But either way, this is a false statement. So we say that 0 does not equal 12. So there's no solution. So let me say it again. When all the eliminators are eliminated and you're left with the false statement, right? 0 will never equal 12, then there's no solution. All right, so go ahead and finish up journal page 21 and have a wonderful Wildcat day.